This is our last panel of the day, but this is still a showstopper. I'm really excited for this group. Laurie is going to take it from here, but I just have to say really quickly that, again, I don't just say, oh, Laurie's great, you should meet Laurie. I'm just saying my life changed after I met Laurie. She had me think about the world and the work and myself differently. So she is going to frame up this conversation in the same way. And I'm so grateful that you're my universe. Take it over.
Thank you, Nina. And thank you, everybody, for staying throughout the day. I know this has been a long day. Our crowd is a little bit thinner than it was at the beginning, but we are going to bring it home with a bang. We're going to walk right into that reception on high energy. And to kick off, for those of you who were not here this morning, I would like to quote Nina Axelson from about 9:05 this morning. She said a really profound thing, and I want to bring it back into your awareness specifically for this brilliant panel. She said, "We have everything we need in our hand. It is what we do with it that matters." Yeah. Did you catch that? Did you catch that this morning? So why is that so relevant to this panel about higher education? We do literally have everything we need in our hand, and these three brilliant humans know a lot about a big piece of what we have in our hand. So I'm going to skip the formal introduction part where you all talk about what you do, and because you say that all the time, and I'm going to do that part for you, and you get to just answer interesting questions. You didn't know this was coming. It's going to be fine, I promise. So we have today on our panel Mahmoud Kabalan, who is I forgot your title, I'm sorry, director. He's in charge of the University of St. Thomas Center for Microgrid Research, which has been mentioned no fewer than a dozen times today. This is kind of a big deal. As he said the other day when we met, not the island, St. Thomas, the one that's in St. Paul, not the tropical island. What do they do there? Sorry, dude, I stole your thunder. You can have the rest of it back, though. So what do? They are about reliability and resilience in our grid. These are two big, important words if you know about grids. Educational programs, research and partnerships, and building human and operational capacity for a 21st century grid. This is a really big deal if you want to keep using electricity. We also have with us Ashley Mahoney. Hello, welcome. She's with the U of M MinCore program. And you have some very impressive stats on your website. I don't know if you know this. 500 plus innovation teams, $50 million in various forms of funding. That's a big deal, people. And they transform groundbreaking ideas into real world solutions. And I cannot wait to hear a lot more about that. And Chris Ghere is our other panelist. Hello, Chris. Chris is with I'm going to let you do this one. What's the name of your organization? It's confusing.
I'm with the Venture Center. We're also under the Technology Commercialization Office.
Thank you, I appreciate that. They help world-class researchers license research patent ideas and establish startups that facilitate commercialization. You also have some impressive stats on your website. 1,500 plus active patents, 3,200 plus licenses, and 240 plus startups launched. Can you believe that? This is who we have on our panel today. So I'm going to ask the three of you, I'm going to kick you off with a question I ask a lot of people. We're going to talk a lot about your big dreams. And I want to hear from you specifically, not the canned stuff you usually talk about, what you see specifically about your organizations. In your idea of a big dream, as we so beautifully got to see last week, does anybody start reading Dr. Ayanna Elizabeth Johnson's book, If We Get It Right? Has anybody started reading that? One. Thank you. The rest of you, you know what your homework is. Go get that book. She talks about, in an optimistic way, what if we get it right? And that's what I want to hear from the three of you. In your worlds, I'd love for the three of you to take a swing at, if we get it right, what happens in Minnesota and beyond? And I want to hear specifically about the part of it that you see. Tell us more about who comes through your group, who you want to come through your group, and what happens when you get it right.
All right, so first I'll say I've been in this role for 2 years, so a lot of those stats were before me, so shout out to Carla Pavone who started the program. Largely who I see and most of what we do are researchers on the university's campus. Thanks to the state of Minnesota, we do have a program through Launch Minnesota to leverage it across the state, so we do get to interact with a lot of interesting people off of campus too, which is fantastic. In my dream, what I would love to see is a representation of what we see across the state. So like Paul, I would like to be increasing some of those numbers. And if we get it right, because we're in Minnesota, and I know this is clean energy, but a lot of what we do is around healthcare and biomed applications. So as I'm getting older and older, I'm super excited about what happens if we get it right. I keep giving Sarkio a hard time that they better hurry up with that cartilage work that they're doing. When I think about clean energy and the applications there, if we get it right, we're dramatically increasing the work we're seeing in Minnesota around that. We have the potential here, we have the people here, we have the infrastructure. Let's go. So if you're looking for entrepreneurial opportunities in this room, that's the space. There's a huge opportunity.
Sure. All right, so I work, as I mentioned, with the University of Minnesota. I work with Ashley quite closely. We advance innovations that come out of University of Minnesota faculty and turn them into startups and help them build the teams and help them find the funding. So in terms of what are the dreams of what could, every technology that I work on, I currently have a portfolio of 60 companies that we're trying to help move forward. Every one of those is trying to improve the world in some way. Some of them are clean tech, some are med tech, some are biotech, but nothing goes on at the University of Minnesota that would be negatively impacting the world. It doesn't get funded by the government. It doesn't, maybe there's some defense technologies I could pull out of that, but the vast majority of what we work on is improving the world. So the technology themselves can improve the world. I think the other part of the dream is right now, if everything's working correctly and this ecosystem's working, these companies would stay here. And I think currently they get their seed funding here. They'll work with Pat Dillon and get their SBIR grants here, but eventually they outgrow our ecosystem and we homegrown these technologies to then ship them off to the coast to scale. And I think my dream would be that they get to stay here to scale.
So for me, I mean, it's kind of a combination of why I stayed in academia and then what we're doing in the center. I think my dream is for us to all realize that a lot of these metrics that we talk about, like reliability, resiliency, all that fun stuff, is essentially they are human-centric metrics. The grid is a piece of machine that's there for us. So I think it needs to work for all of us. So as an idealistic dream, I think just realizing that maybe in the 20th century, 21st century, in the US, the grid was very reliable, but globally, still 2-3 billion people don't have electricity. And in the US, more and more, our grid is not, it's 50 to 60 years old. So we need the engineers that take us into the 21st century here in the US. And my dream is the engineers that we train in Minnesota become the engineers that are desired nationally. So people come to us and say, well, what you're doing here is very unique, very impactful, very much in the real world. We want to hire your engineers that are diverse, that are well-trained, that are well-rounded, so they can make the grid work in California or Hawaii or New York or whatever.
That's fantastic, thank you. A follow-up question to that is, I wanted to kick us off on an optimistic note. I think it's important to see where we're going. I am an architect, and behind you are the drawings of something that didn't exist before they put pen to paper. The three of you sit in a very unique position to understand what that might become. I'd love to hear in a little bit more depth if you can share with us. I know you want the cartilage thing to come online. I'm gonna probably someday want the cartilage thing to come online. What will life be like in Minnesota in 30 years? What will be better about being here than being elsewhere if all of your dreams come true with what you can see from 2024?
Less winter?
I'm not sure that's moving it in the right direction. What's so difficult about it? I'm asking because you see a very unique position, and I really want you to share that with everybody else in the room.
Yeah, I'll take the perspective of where we were 10, 12 years ago. Our startup ecosystem is so much stronger than where we were 10, 12 years ago. And I think you can look around the world and see other startup ecosystems that had a similar trajectory. And I mean, we even, one of our newest hires, Andy over here, he sought out our ecosystem as a budding, burgeoning ecosystem that he wanted to come into. And I see that as our progress as Minnesota and as we're growing. I think both in clean tech today, my background was not clean tech, so I'm learning a lot, and I'm seeing all the connections here and all the momentum. I think projecting that out 30 years, we're not going to be Silicon Valley because Silicon Valley already became Silicon Valley. We're going to be something different, and it's probably going to be focused on deep tech and some of the innovation areas that we have. This momentum is moving in the right direction. And so I would say my best view into what 30 years from now is looking 10 years back and just seeing how far it's come and where we could be 30 years from now.
And I think, so when I started the center at St. Thomas, we are very much a teaching institution. I'm sitting here between the two you folks. We are very much a teaching institution. We're not known for research. It's not that we don't value research, but we don't put emphasis on research, right? So there was a lot of talk of why would you do that there, right? And my answer was, well, why not, right? And I think for a lot of conversations in Minnesota, it's usually like, we don't do this here, right? And I think it's slowly starting to shift. I think we have a lot of things to offer, a lot of great programs, like great catalysts. Now the state is investing more and more in programs. I think we can lead the way. Duluth now is, some people are calling it the #1 climate refugee city in Minnesota. So I think part of it is maybe forecasting that Minnesota's climate might become the most desirable climate in 20, 30, 40, 50 years. And that might bring more stressors up to the upper Midwest. So we might be on the forefront of a place that was, summer was light, winter was pretty rough. That becomes winter is light and summer is beautiful. So I think forecasting that and building a society and building a system that can support those expansions will be pretty exciting.
I think about this in terms of equity of opportunity and access, right? I think there's a lot of opportunity here, and if we're thinking ahead as to what our climate will be like and we're planning for that, there's a huge opportunity. But where we see a lot of the inequities are based around, underserved populations. If we think about access to electricity, where are the stressors? It's often in areas that don't raise a huge fuss if something goes down, right? So keeping that in mind and making sure we have opportunity. I mean, you heard Paul talk about the fact that there's a huge population that have ideas, that have that could take these things forward, that could solve some of these huge problems that we're facing and that we're largely ignoring. So making sure people understand pathways, people understand their opportunities, and getting them involved, right? Giving them access to these opportunities to solve these problems. And we have a lot of people helping address that. We're not there, but my hope and dream is in 30 years, we will be there, and everybody who wants to participate can.
Can you talk a little bit about who finds success in your organizations, or maybe who has found success and who might potentially find success there if they were to join you and get involved in what you're doing?
I'll go. I would say those who are open to feedback. One of the issues we deal with, which is not a terrible thing, but I work with a lot of brilliant scientists. I mean, they're freaking brilliant and they're doing amazing work. And I come along and say something like, that's not gonna sell. And they don't want to hear that, right? So the ones who are open to feedback and are open to being pushed and challenged and will go out and talk to people and be able to hear what they're saying. I had someone tell me the other day, everyone keeps telling me this is not going to work, but it is. He could be right? There are plenty of examples where that's the case, where there were naysayers and they went and built it anyway, and it was amazing. But there are even more examples of people wasting a lot of time and money when they couldn't hear that. So, and it might even just be that you need to pivot a little bit, right? You have brilliant technology, but you need to pivot this way. And being able to hear that, being open to coaching and challenging, I think is really the people who succeed.
Can I ask a follow-up question, Ashley? Is MNCore just for world-class scientists and researchers, or are there others involved in it as well?
So on campus, we have a broad reach from undergrad all the way through med students, PhD researchers. Through Launch Minnesota, we extend that across the state, so that's open to anyone. So you don't have to be a researcher bringing in $500 million grants. You could be opening a restaurant or something like that. So that's a path that we extend. Our education system is based on Lean Launchpad startup. So we provide that for anyone because it's applicable to anyone. And it's all about starting with who your customer is, which a lot of scientists, and that's my background, I was trained that way, so I understand that. We're trained to go in the lab and make something brilliant and then publish it, and everyone tells us how brilliant we are and we get more grants. We are never ever trained to think about what you need to get someone to buy it. And so the mindset for many is, well, it's brilliant, you should buy it. And then we have examples of like the Segway that was brilliant and game-changing and no one bought it. So it's helping scientists understand that. But the foundation, the Lean Launchpad approach is applicable to any business.
So at the center, we would give you world-class access to both facilities and the team. We've assembled an incredible team of 7 full-time staff and many, many students. We have close to $22 million of projects going on now. And we've built a center and a facility that really, in many ways, is a world-class facility that rivals national labs in terms of its capabilities. So we'll give you access to a center that you don't have to go to Colorado, you don't have to go to Idaho, you don't have to go to Brookhaven. It's right here in St. Paul, Minnesota, not the island. But we are able to support companies, researchers, whatever, anywhere from an idea to a prototype, all the way to literally plugging in a generator in our test base, like we're planning on doing with ASA, and we're doing prototyping with NeoCharge. So with that, we can help you succeed faster. We can help you ask the right questions, technical questions. We can help you develop prototypes, and then we can help you if you have a near commercial product. We can help with that. So tremendous resource. That's what we can really offer.
And a follow-up question for you. Is it only for world-class researchers and scientists, or is it for others?
It is for anyone that's willing to reach out, ask questions. We're always happy to chat.
I'll answer your question first.
Thank you, Chris.
So our office only works with University of Minnesota faculty, grad students, inventors, probably with patents that have been filed by our intellectual property team. And so I'm going to call them world-class innovators.
I'm right here.
Yeah. So I will, to your question, who succeeds in our organization? Doers and passionate people. At the end of the day, when you're launching a startup out of the University of Minnesota, it's probably a set of researchers who still have a full-time job and plan to have a full-time job at the University of Minnesota. And the startup initially launches as a moonlight opportunity where they're spending 1 day a week really pushing this opportunity forward. So it has to be people who are passionate about what they're doing and willing to get their hands dirty to do everything from sending out those emails to writing the grant to all the little things that they're willing to do. For them to be successful, they also have to be really self-aware, which I think aligns a lot with what Ashley was saying. understanding their own skill set, understanding what they can and can't do, and what they have the personal commitment to do. The panel right before this asked the question of who you should add to your team really early on in it. I really like that question, but I also find myself talking to those same doers and passionate people that they need to add people who are not like them to their team, because the team is so small at that point. If you have 5 scientists on a team, you're not going to have space on the team for other people. So it's also people who are self-aware to recognize who their partners should be in broadening out their team.
Thank you. And a follow-up question for you. You get these incredible world-class researchers and you say you need some people who don't think like you. What's the opportunity for somebody doesn't have a PhD and a lab at the University of Minnesota to get involved in innovation?
Yeah, so much like Paul was talking about NASA's website earlier, and I would actually say universities across the country are all doing this, we are actively looking for outside partners, because we don't want our faculty to leave the University of Minnesota or St. Thomas. They're outstanding educators. That's what they're trained to do. We have no interest in that, but we want their innovations out in the world. And so we have a series of networking ways that we go out and try to find people to help partner with them. The biggest one is our business advisory group, which is currently at like 450 members. And we go out to that and we seek business talent that are interested. Sometimes we're seeking executives. Sometimes we're seeking project managers who will just help this project along to move it forward. That's our primary mechanism. I'll pass it over to Ashley. We overlap a lot with something called I-Corps mentors that I think is another great way that the university gets involved in the community.
Yeah, so I work and my group works with very early stage. So a lot of times we target students, but they're part of a research group. And so when they have university IP, they qualify to go through a program called I-Corps. No one pronounces the P, it's I-CORPS. And this group, it's really intensive. I should say it's funded by NSF. It's a $50,000 grant. The majority of that money is meant for them to get out and travel and talk to people, which for scientists who have been living in a lab sometimes can be intimidating, depends on the person. But that team also has to have an industry mentor. And despite repeated requests, NSF does not see any reason to pay that mentor, which is very frustrating. So we're often looking for people to pair up with this team. And it might, in an ideal world, you're asking us about that, it would be someone who comes along this team early, helps coach them to make sure they don't make mistakes, and then is there for that team, probably joins the team later on. So it is a 7-week program. It is not 40 hours a week. There's a variety of requests from a mentor, so you can still work your full-time job. But we recognize it is a large commitment for 7 weeks that is unpaid thanks to the NSF.
Ashley, I can see that you can see into the future. If everything goes right, who walks through your doors to help you reach your mission? Who's not there yet?
I think realizing that not everyone needs a bachelor's, a master's, or a PhD degree. My generation, at least my parents, and I see my other friends, we were taught, go to college, get the bachelor's, and then start your life, right? And a lot of the younger generation, the 17 and 18-year-old, where they think they want engineering, but in reality, they're not describing engineering, they're describing a technical degree, right? So I think just realizing that the world is bigger than people with just engineering degrees or master's degrees or PhD degrees. We need everyone to be involved. We need to open our doors more. Sometimes we even need to tell people that the door even exists for them to walk through it. So in my ideal world, people realize their potential, realize their options, and can freely select how they want to move forward with their life.
Yeah, I would say that people are thinking about this opportunity. Like in my mind, as thinking back to 18-year-old, that's a long time ago, I was, entrepreneurship, starting a business, like that takes a lot of money. I don't have that friends and family. Like, what would that look like? It was never on my radar because I didn't think it was possible. When we think about science and tech, you're actually, if you go through a university, you're actually supported by that university. The university owns the IP. They're vested in you succeeding. So there's actually, in some ways, a lot lower risk for students. I talk to middle schoolers about this all the time, that this is a viable pathway to think about. Who's coming through our doors? One of the struggles I think that Chris already alluded to is building teams, right? My scientists don't understand market analysis. They don't understand pricing strategies. I need a wide variety of people to help them because nobody's gonna get a high-tech innovation to the market by themselves. At least that's incredibly rare. So they need a lot of support along the way. So creating this matchmaking is very difficult. So if people would just randomly show up in my office who are ready to jump on teams and help, that would be fantastic.
The one thing I'll add to what Ashley says, because we overlap on this same problem, is the realities of our networking overlap exactly what Paul from Brown Ventures was saying earlier. It is a networking thing. We do have limitations to our community, and we're all, I would say, hoping to get more BIPOC founders in our startups, hoping to get more women-led startups. We have a good representation in terms of our scientific teams that tend to come to us. We have okay representation. But in terms of the actual CEOs leading those companies, we drop off there. And so the ideal world, I would say the representation is the same one that the previous panel was talking about.
I love that. And I should be a little bit more transparent that I obviously am taking you in a very specific direction. Like Pat, I grew up in small town Wisconsin, and I call them pickles too, even when they're still on the vine. I love hearing you say that. There's a lot of innovation happening in barns, in garages, in sheds, in somebody's family's old building that isn't being fully utilized. And I wanted to proactively dispel this widespread belief that you have to have a PhD and you have to be an engineer or a scientist or you have to have a lab at a well-known institution in order to make a dent in climate. And I guess my last leading question is going to be, that's not true, obviously, based on your answers. You have access to incredible talent being in the organizations that you're in. And I just want to reaffirm that you've said it takes a lot of different kinds of thinking. It takes different skills and different backgrounds, and having a little bit of diversity on your early founded leadership team can make all the difference in the world. So if you could summon a magic wand and wave it, what would change about your organization in order to really move the needle towards the direction you know that it needs to go in? And I'm a gregarious extrovert just like Nina, but I can hold an awkward silence like no one else. I don't mind it, Nina, not at all.
So one thing you said got me thinking about a startup that you should keep your eye on, which is called Novoso. It's an undergrad student at the U. I think he's a business major, I'm not even sure. He has created basically a Roomba for clearing your driveway of snow. And I talked to him, and it's got sensors, it's mechanical. I'm like, but you're a business major. I'm like, where did you learn all this? He's like, YouTube. Right? You don't need a PhD. You don't need a high-end lab. There's another undergrad group I dealt with that was doing concentrated acid in their garage. We had to talk about that. So there are safety considerations that sometimes you do need a higher level lab that has hoods. So think about your neighbors when you're doing some of these experiments. But I think in this day and age, all the information that people want to learn is on the internet. So if you are really a go-getter, I don't think you need some fancy degree, and you can do a lot of things in your garage. You can partner with people who are at universities, and if you need lab space, so there are opportunities that way. And I talked enough that I totally forgot your question.
You nailed it. You did great.
All right, I'll answer it from the perspective that higher ed, and I would say at least the University of Minnesota, we start with a research project that the federal government has funded. And that research project has probably taken on $4 to $5 million and taken 4 to 5 years to complete. And now our office is tasked with trying to commercialize that. In business school, that's not how I learned how to do innovation. In business school, you want to go out and you want to understand the customer need. You want to understand how you can solve that need, and then you want to innovate around that need. We're forced to do the opposite. And so there is an advantage that people not in higher ed have, that they can take that process to really understand what that customer need is and then do their innovation. Faculty sometimes do that, but I would actually just say it's not in the academic process, and you can probably speak to this better than I can. They're on a mission to discover new fundamental science, differences in science. And our products tend to be a byproduct of what came out of that research. And so in their effort to push their scientific field forward, they spin out something that might be commercially relevant, and we get to work on it. So I would say that the general premise of your question is, yeah, there's advantages if you aren't involved in all that and you want to move fast instead of speed of academics is pretty slow. At the same time, within the institution, you get a lot of resources that people otherwise probably wouldn't pay for. So,
if I understand the question correctly, I mean, what I would desire is for people to shed, or for all of us to shed the boxes, the mental boxes that we build around ourselves. I see it all the time. I see it in my students. I see it in working professionals. I mean, one of my female students, top students in her class, 6 years ago walks into my office during my office hours, says, engineering is not for me. People are telling me I should go into business. Like, okay, well, who are these people? You know? I mean, what do you want to do? You're a clearly brilliant engineer, brilliant young person. Thankfully, she stuck with it. Now she's a working engineer. Sometimes in the center when we're doing research, can we connect this inverter to this diesel generator? You get in touch with the support engineer and like, oh, what you're trying to do is literally impossible. It's like, okay, well, what is this impossible you're talking about? It's an engineered system that we can sit down and just think about it and make it work. So just shedding in general, shedding these boxes that sometimes are frustrating. Put a box, I'm an engineer. You put a box, I'm a businessman. You put a box, I'm not an innovator. Just shedding those in general is what. And I remember that story because Nina, when she visited me maybe 6 years ago, so a shark, just like some other animals, a shark, if you put it in a small tank, it would only grow to the size of that tank. You have then to move it to a bigger tank for it to actually grow. Not only sharks, but I forgot the technical term of it, but there's a lot of animals that way. So when you build the fictitious box, just like an elephant that you can just chain, because you chain a baby elephant to a tiny pole, that elephant will grow up thinking that they will never be able to get away from that pole. So you see these massive animals that are chained to a very small pole. So in education, I think just sharing those ideas, encouraging people that, you know, you can do better, you can dream bigger, and just execute.
Could you talk a little bit about what you have seen be possible when people do shed those smaller tanks or the twig that, you know, keeps them trapped, those beliefs that keep them small? What's possible? What have you seen?
So it's some professors call that the bug because you see it in their eyes. It becomes that intoxicating. Both, it's a relationship because you can see it in someone's eyes where like it clicked, right? And I mean, the human mind, we still don't know how it works. It's just this unbelievably complex system. So I think we can achieve whatever we desire and we put the effort towards achieving. You look at the people that when we went from humans cannot fly, period, impossible. 66 years later, we landed on the moon. I mean, 10,000 years to fly, and 66 years to just land on the moon. Just because a couple of people are like, you know what, the impossibility is not there. I'm gonna see what's possible, and I'm gonna keep working towards it. We've achieved incredible things.
So one of the things you're talking about is that once you see it happen, it becomes real. And having run for the University of Minnesota as a competitive distance runner, go Gophers, one of the things that happened in distance running is that everybody tried to break the 4-minute mile forever. They got close, they never made it. Somebody broke it, and then all of a sudden a whole bunch of people broke it. This is what you're talking about, Mahmoud. I would love to hear a story. You've seen things that we haven't seen. Can you help us see what's possible?
I think one of the biggest things I see, and especially for people who sit in a room and feel like they don't belong, being a female coming through science, that was often me. I now have a daughter in the same situation, but it also happens to BIPOC students. It happens to people who come from rural upbringings who maybe didn't have a strong background. I heard a story from someone in Mississippi who their science class was watching YouTube videos, which maybe in some cases that's better than, let's just say it, the football coach teaching science. So I think my dream is for people to understand that, and this I get this from Jay Sri Saith, who's at 3M, about I'm not the science type. Well, I'm not smart enough to go into science. I'm like, everyone I knew in my PhD program who was brilliant actually didn't make it through because they're too frustrated by things that don't work in the lab. And they end up going and finding something else and doing something else. So it's not about brilliance in surviving a STEM major or further. It's actually about resilience. And if we can help normalize failure, we talk about that all the time in the startup world, right? Failure is a learning opportunity, but we don't talk about that in freshman chemistry. We don't talk about that in freshman calculus, right? And I saw my daughter go through this, right? Struggling in math, and I was constantly coaching her. It's okay, worst case scenario, you retake the class. That's the attitude that a lot of males have had for years that underrepresented populations didn't understand. I failed my first test. Well, I'm a failure. I'm not meant for you were talking about the human brain. It's a fascinating thing. So just broadly helping people understand, if you're curious and you want to solve climate problems, there's a role for you, whether it's getting a PhD and doing something or how many people do we need in the trades? That number is growing exponentially, right? So there's a role for you. So somehow normalizing that is a huge dream.
I'm trying to think where I can add to the conversation. The best area that I see people changing the most is back to that initial trait of self-awareness. So most people that I work with want to be entrepreneurs. They're already ambitious. They already believe in themselves. They are trying to convince others to believe in them as well. And so it's not so much around that ambition that I end up seeing that change as much as I see it in their self-awareness of understanding that who they need to bring into the team to help build this with them, how they can augment themselves to give themselves to enhance their capabilities. And that is a journey always with every startup team, because most of our startups come in and they come in saying, I want to have control. I want to drive this forward. I know the right way to do it. And it is a process to bring someone off that to understand, no, the most successful companies in the world, they might have one figurehead, but they have a massive team behind them. And there's a big effort by us to bring people along for that journey. And so once people start to recognize that, it really opens doors for them to do other things. It really opens doors for that organization to scale, for them to find investment. And that's where I see the most aha that I would say is different than, one of the things I didn't mention early on is the very first step in my process is I hand them off to Ashley. And Ashley takes them through her program, and actually Pat Dillon as well takes them through her program as well. So I overlap a lot with both of them and their journeys of our startups.
So I think, I don't even see Nina, so I'm just going to say we have time. Is there any questions from the audience that you like? Yeah.
What do you think that the possibility is that the university will have within 7 to 10 years? All renewable energy, all clean renewable electricity without buying RECs, renewable energy.
So the question was, what is the potential at the university in 7 to 10 years of all renewable energy without buying credits? Chris, I caught your pun. Are you plugged into that at all?
I don't know that we're the ones who are going to answer that for you. You did say they hired someone? Chief Sustainable. I don't know that we're going to have your answer on that one.
Sure.
Well, wait, see, Thomas might have one.
So, with current technologies, if you're asking about generating green energy, right? With current technologies, university campuses would be really difficult to get us to 100% renewable. Solar, if you put a solar panel sometimes literally on every single square inch that you can find on a campus, that's not going to be enough. Wind is problematic, usually in urban areas. You can put, so you can, but with current technologies, with a limited geographical space on a university campus, it would be very difficult to get to 100% renewable.
There's a lot of youth-focused education programs like Course Robotics, Girls Who Code, or a couple that come to mind. In higher education, to what degree are you seeing those programs helping the program?
So the question is, there's a lot of youth-focused programs specifically on STEM, and the question is at the university level, are you seeing the impact of all those programs on younger students?
I would say yes. I mean, I don't have any data to support that, but largely what those do is build awareness. And I think it also helps students understand maybe what they do like doing and what they don't like doing. One of the most impactful things in my experience was doing an undergrad research project in material science, in which I learned I did not want to do material science. That was super helpful, right? If you do coding, maybe you're like, either this is for me or it's not for me. So I think it's created a lot of awareness, which is huge. I struggle a little bit with now a huge push to go into STEM because that's where you can make the most money. And part of that is tied up with the cost of higher education. But I think largely it's done two things: create awareness and help people who may not have seen themselves as a STEM person start to think that way.
I can give you an answer from the education research. So in the 90s and the early 2000s, people were like, if we talk to folks and when they're 15, 16, 17, we can get them into STEM, right? That proved to be elusive. It wasn't super successful. Then people were like, well, let's go to the 12, 13, 14-year-olds, right? And it's kind of a shaky success story now. So now we're realizing that maybe we even need to go to the 5 to 10-year-olds, right? And the other day at a conference, I heard a brilliant analogy from a professor. If you want the most brilliant gymnast, you start training them when they're 4 years old, right? And if we want the most brilliant engineers or scientists or whatever, traditionally, I think we need to get them at the 4 or 5-year-old, because a lot of those boundaries and the boxes that I talked about, they start forming, I think, from that age. hey, you're stupid, you're whatever, blah, blah, blah. You know, you can't, you're not smart. So those boxes start to form sometimes from that age. So right now, more and more focus is on go to the 5 to 10-year-olds, and we'll see what the research says in 5 to 10 years.
I would say too, when I first started hearing people talk about engineering in elementary school, I thought, what in the world? I can't even get college students to understand this. And then what I realized was it's all about the engineering design process, and it's all about asking questions and not having one right answer. And I thought, holy moly, that's brilliant. And so if we can really get that at those elementary ages, because what we do is we take kids who are naturally curious and we teach them there's one right answer. And so by college, they're not asking questions anymore other than what's the right answer. So I think the more we can think that way at an early age, just keeping them asking questions, get them designing things, you can get elementary kids thinking about climate change and energy solutions, right? Not at a detailed scientific level, but they can build things, they can ask questions. So I think that's really a huge opportunity.
All right, we're going to wrap up here, and I want to thank our brilliant panelists for sharing insight into your worlds.